Now let's take another example where I would like to convert the set builder form to the roster form involving most of the mathematical properties. Say for example, I have the set U is x such that x belongs to n and x square is less than 40 is the set builder form, and I want to convert the set builder form into the roster form. So I strictly understand the mathematical properties involved here, the square numbers which we already discussed in the previous sessions of the lower classes sessions. So x says that x is a natural number and all the squares of those natural numbers must be less than 40. So I understand that the first natural number is 1. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, 6 square is 36, 7 square is 49. But I halt here because I want only those values which are less than 40. So they form the numbers which are less than 40, but this does not form a number less than 40. So 49 is clearly greater than 40. So all the values of x which are natural numbers and the squares are less than 40 are the numbers which are 1, 2, 3, 4, 5 and 6 are the required numbers. Therefore, my answer for the given question is U is equal to 1, 2, 3, 4, 5 and 6 is the answer for the given problem. So now that we have discussed about the roster and set builder form and also the definition of a set in the introduction of this topic, now comes what are the different types of sets which we have in mathematics is what we are going to discuss in this session. So there might be many different types of sets, natural numbers, integers, real numbers. So these are the different types of sets which we have seen in the real number system. But generally in mathematics, there are many types of sets. The most important of them being the null set or finite and infinite sets. So let's see the definitions of different types of sets in different various orders. So coming to the null set. Is also called the empty set. So empty, the word empty says that there's nothing inside the set. The word null, nullified or empty makes us understand that this set does not consist of any elements inside the set. So when I say take the definition, the set which has no elements inside it is called a null set or an empty set. The other name given for null set is an empty set. It is empty, no elements inside it. So with an example, the notation is that it is denoted with this or this. Usually the null set is denoted with phi. This is read as phi and this is also one of the symbols for null set. Phi or this is how I understand the null set. There are no elements inside it. How do I write the set builder form of this roster form? It's very simple. When I want to write the set builder form of this, I write this as x as that x is not an element inside the set is how I smartly write the roster form, the set builder form of this roster form. So the set builder form of the null set is x as that x is not an element inside the set. There's no element. So this is how I write the null set. The other type of set in mathematics is the Singleton set. The set which we're going to discuss next is about Singleton set. So what is a Singleton set? Single The word single says I am only one. I am single in the class. That means I am the only person inside the class. So I am single. I am a bachelor. I am not married. I am a single. That means I am the only one person. So single is only one element present. So when I say singleton set, it makes me understand that there's only one element inside the set, and that is single. So singleton set is a set which has only one element inside it. There's so many examples you can take. A set which has only one element inside set. For example, I take 4, 9, E. So these are all singleton sets because I have only one element inside the set, and therefore they are singleton sets. But when I take, this is not a singleton set because clearly there are two elements which are 4 and 6 inside the set. Therefore, this does not form a singleton set. Now, with the definition of singleton set, there is one important property which we have to differentiate between the null set and the singleton set. Now, what is the difference between this and this? I want to find the difference between this and this. Many of them assume this to be the null set, but which is not true. To make a note, this is not a null set. If you think this is a null set, then that indicates that you haven't understood the definition of a null set exactly. This cannot be a null set because I have one element which is 0, which supports with the statement that a set which has one element inside it, 0 is also an element. So therefore, this set has one element 0. Therefore, this forms a singleton set with the single element 0. With single element 0. Whereas the null set says that it has no elements inside it. Therefore, this forms a null set, but this does not form a null set because there's already one element 0 inside it. So it is a singleton set, and this is a null set. And this cannot form a singleton set because there's no element inside it. No single element is how I understand the difference between this and this. Singleton set and the null set is how I differentiate those two example problems. So now that we have been continuing with discussing about the different types of sets, now comes the question, is the set countable or not countable? So for example, if I take the set of vowels, I can count them because I know that there are 5 vowels in English alphabet which are A, E, I, O, U. But when I ask a student to stand and read the set of all natural numbers, then he would only read 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. But he cannot read all the natural numbers. It is impossible to count all the natural numbers because there are infinitely many. But when the same student is asked to count the set of vowels, he immediately says A, E, I, O, U and halts at U. So this makes me understand that the sets which are countable are finite and the sets which are not countable are infinite. Very simple definition. So there are two types of sets, finite and infinite sets. So let's see the different types of sets through an example. So here I see that the sets are separated through finite sets and infinite sets which we take separately, and finite sets are the sets which are countable and infinite sets are the sets which are not countable. They are infinitely many. The counting becomes limitless or uncountable. is how I understand the definition. Say, for example, so in this case, I take set of vowels, and in this case, I take set of odd numbers. Is how I understand, because in this case, when I take the example of set of vowels, I can take them as countable, which are 5 in number, and I can write the finite number of elements inside because they are countable. But here, when I take the set of odd numbers, I take it as 1, 3, 5, 7, 9, so on and so forth. But I cannot count them because there are infinitely many odd numbers starting from 1 and ending with infinity. So therefore, this stands an example of finite set, and this an example of infinite sets. The question here comes now. Is phi or a null set a finite or an infinite? So the question here is null set a finite or an infinite set? So clearly we know that a null set is nothing but an empty set which does not have any element. That implies no elements inside the set is what is defined as null set. No elements implies there are 0 elements inside. Mathematically, no is referred as 0. Therefore, no elements inside the set implies there are 0 elements inside the set. So when there are 0 elements, 0 is a finite number. That implies 0 is finite. 0 is referred as a finite value. That implies this is a finite set, is how we conclude. So if I wanted to identify the set to be finite or infinite, I identify the number of elements inside the set. If the number is finite, the whole set is finite. If the number is infinite, the whole set is infinite. As taken with this example, the set of vowels is a finite set because the number of elements here is 5, and 5 is a finite number. So this set is finite, and hence set of vowels is a finite set. For example, when I take set of odd numbers, the number is 1, 3, 5, 7, 9, etc. The number of elements here is infinite, uncountable. Therefore, the set of odd numbers is infinite, is how we define the infinite set. Similarly, a null set is a finite set because the number of elements in the null set is 0, and 0 is finite. Therefore, this is a finite set. Similarly, with the case of singleton set, the singleton set has only one element. Therefore, the number of elements in the singleton set is 1, and 1 is finite. Therefore, the singleton set is finite. So if I take the second note, singleton set, generally denoted with this, is a finite set supported with the number of elements in the singleton set is 1, and 1 is finite. Therefore, this is a finite set. So to continue with the session, if I take a straight line A to B, then number of points on this line AB will also be an infinite set. If I take set of number of points on AB, set of all points, set of points on AB will also form an infinite set because there are infinitely many points on AB. So geometrically, you can identify the different types of concepts which can be connected to the geometrical part. So for example, will be an infinite set. Next, if I take a circle and this is the center and this is the diameter, then set of all possible diameters of the circle will be also an infinite set because I have all possible finite sets. Set of all possible diameters of the circle will also form an infinite set, is how I understand. If I take this is an hexagon, a six-sided figure where my question is set of all diagonals of hexagon will also be not an infinite set, but this will be a finite set because I can draw infinitely many diameters on the circle. I can pick infinitely many points on the line, but I cannot pick infinitely many diagonals. The diagonals are restricted and they're countable. Let's see how many diagonals exist for an hexagon. Diagonal 1, diagonal 2, diagonal 3, diagonal 4, diagonal 5, diagonal 6, diagonal 7, diagonal 8, diagonal 9. There are 9 diagonals which connect one vertex to the other vertex. This is a finite set because totally there exist 9 diagonals for an hexagon. So this can also be connected with a polygon. Set of all diagonals of a polygon is a finite set but not an infinite set. And to identify finite and infinite sets, sometimes we need the mathematical knowledge more advanced. In case of this, knowing the number of diagonals of a polygon being a finite set. So now that we have discussed about finite and infinite sets which are related to countable and uncountable, so mathematics realizes the importance of identifying the number of elements in a set, and hence there's a new concept introduced called the cardinal number. Identifying the number of elements of a set is very important in justifying the set for a finite or an infinite set. Therefore, let's see what a cardinal number is. Now, cardinal number is nothing but it is the number of elements inside the set. So cardinal number is nothing but the number of elements inside the set when you count them. So for example, but before this, it is denoted by set A. It is denoted with n of A for any set A. The notation for cardinal number is n of A. So, for example, I take A is equal to A, E, I, O, U. Then my cardinal number for this set denoted by n of A is the number of elements inside the set. 1, 2, 3, 4, 5. So the answer for this is 5. The cardinal number of set A consisting of all vowels is 5. Similarly, is the question. The singleton set is a set which has only one single element inside the set. Therefore, cardinal number of a singleton set is always 1. This is always for any singleton set, the cardinal number is 1 always. Next, what will be the cardinal number of null set? As we already discussed, we need to revisit the definition of a null set to identify the cardinal number of a null or an empty set. We know that an empty set doesn't consist of any elements, the number of elements mathematically in a null set is 0. Therefore, cardinal number of null set is the number of elements which is 0, and hence of the null set is 0. Cardinal number of phi is 0. Say I take the cardinal number of integers. The numbers which we identify in integers range from -infinity to infinity. Therefore, there are infinitely many numbers which exist in integers. Therefore, cardinal number of z is tending to infinity. We cannot exactly identify the exact value. Therefore, the cardinal number of integers tends to infinity. Now, I want to take an interesting example for finding the cardinal number, because this example makes us understand on how important is realizing the set before realizing its cardinal number. So for example, I have set of all odd numbers which give the remainder as 0 when divided by 2. The whole question has many mathematical properties hidden inside the statements. So it is very important to identify and understand this statement before we generate the roster form of this statement and then find the cardinal number. Now, set of all odd numbers. We all know what are odd numbers, but the condition, the post condition out here is that the set of all odd numbers which give the remainder as 0, we need to pick only those odd numbers which make the remainder 0 when divided with the fixed value 2. So, how many numbers exist which give the remainder 0 when divided by 2 is the first identification we need to make in case of this example problem. So when I take the set of all odd numbers, so let me pick up all the odd numbers 1, 3, 5, 7, 9 and so on and so forth. Now I want to divide each of the odd number with 2 such that I get the remainder as 0. Is there any possibility that when I divide an odd number with 2 I get the remainder 0? So let's test if it is possible. So let me randomly pick one of the odd number, say 5, and I divide 5 with 2 and see what is the remainder. 1 is the remainder, but I want that number which gives the remainder as 0. So this does not work out. So 5 fails in coming into the set as desired out here. Similarly, I pick up 9 and then I say I divide with 2, then let me see what is the remainder. 2 4s 8 and 1, and then again the remainder is 1 but not 0. So I make a conjecture that any odd number is not divisible by 2, therefore definitely the remainder will not be 0. So this contradicts the statement that we cannot pick any number which gives the remainder 0 when divided by 2, the number being an odd number. So therefore the whole of the set does not consist of any element or any number which satisfies the condition that it must be an odd number with remainder 0 when divided by 2. That means there is no element. No element is identified as no element or this. So the whole of the set is identified as the null set because no element inside. The null set instead is again identified as the cardinal number of S is 0. Therefore, when I wanted to find the number of elements in the set of odd numbers which give the remainder 0 when divided by 2 indirectly gives me a null set. Thus, the cardinal number of this set is 0, is how I identify by generating the set and then identifying the number of elements.